I'm going to describe how to use the little bit of diagram here to map and to construct a circuit on a strip board. So a strip board is something which looks like this. We've got a little diagram of it here. It is a board with strips of copper along it, and we have holes in here to insert the components and then to solder them. I'm using a little diagram of what it looks like, and you will have a piece of paper with this printed on, and you can use this as well. And this is the view on the copper side, where these are the strips of copper, and we will be inserting the components on the other side so that the lead will stick out through here, if you like. And then when they stick out, you will solder it and clip off the leads. Okay, so the view that we have here is on the copper side, which is the bottom view of everything, if you like. And this is the top view of what we are going to use for the IC. So we should be used to this. You will find this in your reference sheet. The top view of an integrated circuit, or IC. Pin 1 has the indentation there, or if that's missing, we look for the notch. So that's pin 1 from the top view. But if we're looking at the bottom view, which is how we see it from this diagram, because we are inserting it from the other side, then pin 1 now is on the top here. Now I'm going to map this circuit diagram onto the board and build it so that we'll be able to construct it later on and solder this whole circuit here. Now, if we look at the diagram, we have pins 2 and 3 with a lot more stuff going on here rather than with pin 6. So when we place the IC, we're going to place it so that pin 2 and 3, which is a bit out here, will have more space above it. So we'll say above it there, so that we can have space to put all these components. So what we'll do is, first, we'll use this diagram of the strip board that we have, and this is a 9 by 25 strip board, because it has 9 holes this way and 25 holes down this way, and you get boards of different sizes. The other thing that I want to point out is that this is the layout for the IC. So pin 1 there, I've drawn it kind of extra dark there, 2, 3, 4, a blank row of holes, another blank row, and then 5, 6, 7, 8, and that's how it fits onto there. The other one that we'll be using is the variable resistor here. The variable resistor has 3 terminals, 1, 2, and 3, and the way that it's laid out physically is 1, 2, and 3, and it's 3 holes across here and 5 holes across there. So let's get started. We've got the diagram here, and we will be highlighting it as we go along, as you are used to now. Let's first identify the rails. So we're going to use one rail here as a positive rail and another rail here as a negative rail, so we know that we can connect the circuit to it later on. So we've got a positive rail and a negative rail here, and we'll choose one. We'll say this is positive, and we'll say that this is negative. So I'm just going to put an arrow and indicate that. So this will be, oops, not this one, but this one will be my positive, and this one will be my negative. Okay, and we'll be connecting wires to that later on. Now, let's connect our IC somewhere here on the board. Okay, so remember our pin 1 now is on top here because we're looking at the bottom view, and we want to give space for pins 2 and 3 to have more connections. So I'm going to place my board, my IC somewhere here roughly. Okay, so I will make this pin 1, 2, 3, 4, blank row, 5, 6, 7, 8. Now, when we place it there, because this is a strip of copper, we don't want the copper to be connecting these two pins across. So we will be using a strip board cutter eventually, and we will cut it above the row of holes there. So we cut the strip of copper at the holes in the board there. Okay, so in this case, what we're going to do is we're going to cut it here. We will put in X, 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 X. Okay, and each X will be a cut that we place, that we make on the strip of copper, so that this strip of copper is different, or will be a separate connection from this strip of copper. And you will have a cutting tool that you can use for that later on. So we've identified our plus and we've identified our minus. So let's just use our highlighter. We've identified our plus, we've identified our minus, and that's all done. Now let's look at the connections first. Let's connect the LED D1 and R2, the resistor, to pin 6. So let's look at this. This is pin 1, 2, 3, 4, 5, 6. That's pin 6, and that goes to the LED. So we're going to use this strip of copper to connect pin 6 to the LED. And the LED has to go into a different hole. We can't use the same hole. And we'll move, and we'll leave one row blank so that we have a bit of space, and then we'll use this hole there to connect the LED. So we've got an LED there, and we're going to, let's connect it to there. So it's pin 6, and we've got an LED there, and we're going to connect it to this row there. Now if you look, this strip of copper has no other connections, so we're using this to connect our LED. Okay, I'll just write D1 there so we know that's the LED, and we're going to connect it to R2, which is the resistor, to the positive rail. So this is my positive rail, and I want to connect it, use R2 connect to my LED there. So I will put my R2, I'll leave a blank row just for space again. This is my R2, oops, not much space, but you know what it means, and I'll connect it across there. So that is R2. So the way that we do is we've connected our LED, remember the polarity, be careful of that, to there. The copper strip connects it, so we've got our LED there, our copper strip connects it to R2, which goes all the way to the positive rail. And we just want to make sure that this strip of copper is not connected to anything, so that we don't clash with any other connections. There isn't right now, so we're good. And what we'll do is, since we've made the connection, we will highlight this. This is done to pin 6. Next, we're going to connect pin 7 to the positive rail there. So 1, 2, 3, 4, 5, 6, 7. So we are going to connect this pin here over to the positive rail, which is over here. So this pin, the copper strip, goes along here. So I'll use this hole here. Okay. So I leave another blank row here just to make space. And I'll use this here to pin 7. This is pin 7, and I'm going to connect this to the positive rail. So what I'll do is I will just put a wire one end in here, and let's try that again. So a wire to pin 7, which is there. 1, 2, 3, 4, 5. Let's see, 1, 2, 3, 4, 5, 6, 7, and it's down there. So pin 7 to the positive rail there. Oops, there we are. Okay, and now that we've connected it, we highlight it. Job done. Next one will be pin 4 to negative. Pin 1, 2, 3, 4 is there, and we want to connect it to the negative. So I'll leave one blank row there for space, and I'll connect it across this way to the negative. Okay, so that's, oops, and let's draw it across this way to my negative. So that's done. I will highlight that to show that that's done. Next one is, let's do this one. Pin 3 goes through resistor R1 to the positive rail. So pin 3, that's 1, 2, 3. So somewhere here, okay, I want to connect this pin, pin 3, to my positive rail. So let's say I'll use this one up here. We've got lots of space, so we'll connect pin 3, 1, 2, 3 from there to my, oops, there we go, this is R1. Okay, and highlight there. So R1 now is connected from pin 3 to the positive rail. Next, we'll connect C1. So C1, remember now it has a positive and a negative. It's a polarized capacitor, and I'm connecting it from pin 3 to ground. So let's say that's pin 3. I'll leave a space, so it's from there to ground. Okay, from there to ground. So let's connect our, from there, my capacitor to ground. And this is my positive, that's my negative. And so that I can see the polarity there. So I've got pin, the capacitor, C1. I'll write that there. So I can see where it is. And it's connected to ground this way. And what I'll do is, since it's done, highlight, that's finished. Now I have TP2, sorry, not TP2, VR1, which is the variable resistor, VR1. So remember, it's laid out like this. Pin 1, pin 2, pin 3 in a kind of a triangle. Pin 2 is this one here. Okay, pin 2, pin 2. So I will connect it to pin 2 of my IC as well. Pin 2 of my IC is here, and I'm going to use maybe up here, leave a bit of space, and I'm going to put this one here as my variable resistor. Okay, so pin 2 goes up, leave a bit of space, so here's pin 2 of my variable resistor. Now remember, this goes pin 2, and then it goes 1, 2, 3, 4, 5, and then I have two end of a pin on either side. So let's see, it's pin 2, sorry, the pin is there, 1, 2, 3, 4, 5, that's up here, and then it's on each side there. Now when we place it, let's just check. This is going up now to the positive, and this one is going to the negative there. So since this one is nearer the positive, I'll use this. This will go positive, this one will go to negative. Okay, I will leave an empty row there, so there's a bit of space again. So my positive is, I'll put on wire from there to positive, and negative, I'll put it across to there. Okay, and now that it's done, highlight to mark it off, and this one here as well. Now at this point, it's really important. It is crucial for you to check that this connection here is not interfering with anything else. And so we look through, well, it goes all the way to pin 1, and we do not want that to happen. Okay, we don't want this to be connected to pin 1 of the IC. So what do? We make a break or a cut in the copper. So I'll put a cut there. Oops, I'll put a cut there, and X, to show I'm going to cut the copper there, so that now I've got this strip of copper here connected to the positive, this strip of copper here connected to the positive, and it is broken and it won't interrupt, and it won't be connected to pin 1. Let's check this one as well. We're using this connection, this copper here, to connect this wire to this pin, but I do not want it to be connected to here. So I need to make a break. Let's choose a convenient place. Maybe here's a good place to put a break there. Okay, so I'll put a break there, and X, and I will make a cut or a break in the copper later on. So we've now made sure that this connection here is isolated from this connection, and that is what we want. Okay, looking back at our circuit, we've also made this connection, so we'll highlight it before we forget. So we've almost finished, except for switch 1. We're not using a real switch, we're just using 2 wires. Okay, and we have blue wires, let's say, which we will be using in the lab. So that one will be connecting to pin 3 of the IC, and the other one of the wire will be to ground. So pin 3 of the IC, that's 1, 2, 3, 1, 2, 3, and anywhere along this row. Okay, so maybe I will use this hole there for my switch, which is convenient. Okay, so this one will go out to my switch, SW1. Okay, SW1, and I will highlight that. Oops, wrong one. So this connection is now done, and the other connection goes to ground. So just for convenience, I'll take this connection there. This also goes to SW1, and highlight to show it is done. So in reality, we'll be just soldering 2 wires there. We'll have the bad ends there, which we will touch together to close the switch, and that will be SW1 in place. Finally will be the connection to the battery here, okay, or the power supply. So we just need to have some wires there to connect it. So the first one, we put a positive red and a negative black. Okay, so where is our positive? Our positive is this rail, so I'm going to solder 1 red wire there for positive, and then for my negative, I'm going to solder 1 black wire there, negative, and this will be going to the power supply. I will clip that to the power supply. So positive there, negative there, all done. These are just arrows to remind us what the rows were, or what the strip was. So this is not a connection, it's just an indication for us to remember what is what. These are the actual wires that we will use to clip onto the power supply. Okay, so the final thing that I just want to do is maybe do a dotted line or so to show that this is VR1, and we know that's there, and everything's been highlighted, job done, and we have mapped out our circuit. When we create our circuit, remember that this view is the bottom side. We will not actually see these components because the components will be going in on the other side. You have to remember that. That's really important. But when you insert it, you will have the leads coming out this way, and then you will solder it, clip it, and that will be the circuit constructed.